Hello, this is Ryan Wong, and I'm going to be going over homework problem number 3. The question is, find how much energy is stored in length B of the coaxial cable. And the diagram is up here of the coaxial cable with the inner wire and the outer wire. The inner wire is of radius r sub 1 with the current I traveling in the right direction. And then the outer wire r sub 2 where the current is traveling to the left, and this whole coaxial cable is of length b. So to solve this problem, we're going to have to use the equation for the energy density, which is equal to the magnetic field squared over 2 mu naught. So to calculate the magnetic field, we're going to have to apply Ampere's law. And when we do this inside the first wire, we're going to get the B field is equal to 0 because inside this first shell there is no current. So I enclosed is 0, so the B field will be 0. When we apply Ampere's law from R1 to R2, we do have a current enclosed because of this wire, the inner wire, which is current I. So when we apply Ampere's law, the B field is going to be equal to mu naught I over 2 pi r. And since the B field is not uniform, because the farther you get away from R1, the less the B field becomes. So we have to integrate from R1 to R2 over 1 over r because everything else is a constant. And when we take this integral, we get mu naught I over 2 pi ln of R2 over R1. And since we were interested in finding the total energy across this whole coaxial cable, and we just found the B field of just this one sliver of dB, we need to multiply the B field, this energy density, by the whole volume. So we're going to have our B field, which we just calculated, mu naught I over 2 pi ln of R2 over R1 squared, because the B field is squared when we look back to the energy density equation, all over 2 mu naught. And since we want to know the total energy across the whole volume of the coaxial cable, we have to multiply the energy density by the volume of the coaxial cable, which is pi R2 squared over B. And this is in joules, which I did not write, but the total energy is here and it's in joules.